So good afternoon once again. Good evening. I hope I am audible.
Yes, you are audible.
So shall we start once again?
Yes, ma'am.
Okay.
Yes, ma'am. Yes, ma'am.
So right now I'll be sharing one document with you um, to make you understand what are the hyperparameters, what is the role of Python. You will understand lot many things with that example. Okay. This example is of how to create single neuron in Python language. Okay. So we are not using any ready-made functions of Python. It is very pure basic language. You can do this work in C, C++, Java, whatever the language of your choice. Okay. So I'll share one document and let's see whether it makes sense to you or not. Pages. I was trying to put it on slides, but I found it to be slightly more difficult to put it on slides. So let's get started. Mm. Let me share the screen. Is it visible?
Yes, ma'am.
Okay. Is it readable also, or should I? Is it readable? Font size, everything?
Yes, ma'am.
Okay. So we are trying to what we are trying to do is, if a person is hungry and food is available, these are the two fields which are input. Just give me a second. So this is the input data. If a person is hungry, food is available, then we'll say a decision is to be taken whether eat or not. Okay. Eat will be active or not. So if both the things are true, then eat will be active. Now it is something like the AND gate only, right? If both the inputs are true, then this output will be true. Otherwise, for all other cases, it will be false. Now for this decision, whether to eat or not, this is just a toy example. Hello. Hello.
Yes, ma'am.
It's audible, ma'am.
Hello. Yeah. Sorry, I was getting a phone call. Okay. So I hope this table is quite clear to all. Now we are writing the function predict. Okay. So if this is not known, so if this is hidden, like eat is not there. Okay. If we hide this field altogether, then hungry and food available. So decision has to be taken whether eat is active or not. So we are defining a function. We are writing a function in Python. So input is hungry and food available, right? This should not be strong. I don't know how it's got. This should be eat. So initially eat is 0. If hungry equals to 1 and food available equals to 1, eat equals to 1 and return it, right? Okay. So this function is predicting what will be the value of eat. It is actually computing. Now we give input predict to this function like 1, 1 we give. What do you think will be output for this print? Obviously it will be 1, and for rest other prints it will be 0. I hope this much is clear to all. Yes,
Yes,
or
ma'am.
no? Yes. Okay. If in between you do not understand anything, please let me know. Okay. So initially what we have done is we have just created, actually these are the notes which I created for explaining some concept to some of the MTech candidates. So I'm sharing that with you. So actually we begin with random prediction. We just simply have a predict function and we are predicting. That's it. Okay. So we'll gradually refine after multiple iterations until we achieve a good enough result. Now, what is a good enough result? You will come to know after some time. So we will do this functionality, this thing using the behavior of a neuron. Okay. So can you see this figure? So the input is going hungry and food available inside the this model, and it is doing some summation. And if summation is greater than 1, then the output will be eat. If summation is less than 1, then obviously eat will be inactive. And the weights initially, weight 1 for hungry is 2 and food available is 0.5. Is this much clear to all? Because there are
Yes,
two
ma'am.
inputs, so there are two weights. These inputs are nothing but the features, right? So we have the weights for the two features. Okay. Okay. Now we are creating a neuron class. Again, this code is written in Python, but it is absolutely okay to write it in Java or C++ or any language of your choice. Okay. So we are creating a class neuron. So we are creating a neuron which is capable of predicting something. Okay. And we will be training this neuron. Definite, this is actually the constructor in Python. Def underscore underscore init underscore underscore, and self is like a self pointer that is there in this pointer in C++. So self w1 equals to 2 and self w2 is 0.5. These are like object variables, right? For every neuron there will be instance variables. So W1 is 2 and W2 is 0.5. And we have a predict function, self, hungry, food available. That is how we define a method within the class. Neuron is a class, so self will be definitely the variable. Over here, argument that will be passed. So it equals to 0, and the same function that we wrote over here, except we have multiplied it with weight. So hungry into self dot w1 and food available into self dot w2. If it is greater than 1, then eat equals to 1. I hope this is clear. Is this class neuron clear to all? We'll be slowly, gradually, we'll be enhancing this class and we'll completely show how training is happening and how we are testing it also. Right? Anyone having any doubt in this, please let me know. So now what we are doing is we have created a
Excuse me,
neuron.
ma'am.
Yes.
And kindly explain that weight 2 is equal to 2, weight 1 is equal to 2, and
See,
weight
we
2 is
we
equal to
have picked
0.5.
them randomly. Okay. These are the initial weights. You can choose anything that you feel like. Okay. Weight 1 is 2. You can choose any weight of your choice. You want to put 1, you want to put half, you want to put 0. That is your choice. Right? Is it clear?
Okay, ma'am.
Okay, you can put any weight of your choice. It's totally random onto you. Okay. And later on, you'll see we'll randomize that as well. Okay, so now we have created a neuron and we are using this object neuron to predict. So we are calling the method predict on neuron. So neuron.predict 1 1. You can think of now what will be the answer. Now this one will be multiplied by 2 and the second one will be multiplied by half. So this is 2 plus half is greater than 1. So answer is correct. For the next input 1 and 0, what do you think will happen? So 2 will be multiplied 1 and 0.5 will be multiplied with 0. So 2 plus 0 will still be greater than 1. So for this input also, currently the neuron will say eat. Now for this input, what will happen? 0 multiplied by 2 will be 0 plus 1 multiplied by 0.5 will be 0.5, which is not greater than 1. So it will remain, it will be 0. Right? And for the last one, obviously, both are zeros. So it will be multiplied by 0. And it will not be greater than 1. So it will be 0 in last case also. So it will be 1 here. It will be 1 here. Now, what is the desired answer? What is the data saying? The data is saying this. This is my data. Right? This is saying if both are 1, then answer is 1. But my neuron currently with these weights, it is giving me this answer. So currently, the neuron is not giving the correct answer. For 50% of the input values, it is giving me the right answer. And for 50% of the input values, it is giving me wrong answer. Is this much clear to all?
Yes, ma'am.
And where do we get the values of weight from? Obviously, that is what is machine learning all about. So initially, I told you, what is machine learning? It is just the training of weight. Somebody may tell me these are the weights for each of the feature and my work is done. Okay. So now let's make changes. Okay, we have put 2 and 5, and if you run, this is the answer. We are getting 1, 1 and 0, 0. For these two values, these two inputs, answer is 1. And for the last two inputs, answer is 0. Now, so there is only one mistake. Actually, there is only one mistake. This prediction is incorrect. The model, the neuron, is predicting the second as incorrect. So let's make changes. Okay. We can put both the weights to 3. What we do is, we are randomly doing it. So weight 1, we put 3, and for the weight 2 also 3. Now what will happen when weight, see, again this model will work. Predict 1, 1. So 3 ones are 3, 3 ones are 3, greater than 1. 6 is greater than 1. Yes, so it will give me 8. 1, 0, 1 into 3 and 0 into 3. So answer is 3 greater than 1. Right. For this one also, 0, 3. Now this is right. This is also saying 8. This is also saying 8. And last one is saying 0. So 8 is not there. So when we made both of them 3, now we are getting this answer. So now 2 of my answers are incorrect. Okay, so we have made 2 mistakes. Now let's make the weight as 0.6 and 0.8. Again, this we are doing purely as per our own choice. Okay, it's like randomly we are putting any weight. Okay. So now when we put 6 and 8, what is happening when 1, 1 is there? So 1 into 0.6 and 1 into 0.8, it makes it 6, and 0.6 and 0.8 is 1.4 greater than 1. So answer is 1. In next case, when it is 1 and 0, so it is 0.6 plus 0, which is less than 1. So it is 0. For another one, it is 0. For last one, it is 0. So these weights seems to work good for us. Okay. So we have all the correct answers. Okay. So you can play, in fact, with this is not the only correct answer, right? You can have few other answers also where you might get the correct answer. You can play with these weights and check what all weights give the correct answer. Okay. Now this we are doing randomly, manually, right? This is actually what is learning all about. You are putting some weight, then you are figuring out this is wrong, then again you are figuring out something is wrong. Okay, but you are doing it manually. We want this to be done by neuron. Neuron should learn it. Okay, so we can adapt our prediction function to fit for any input output pattern. So we need a learn function that takes the inputs and output, then applies a process to update the weights accordingly. Now let's see the neuron again. So now we have imported a random library. A random package is there, so which is going to assign the weight randomly. Initially, we were assigning it as per our choice. Okay, 1 and 2. Now we are using random weights. Right? So what is happening now is, now neuron is there, initializing self W1. Earlier we were giving 2, now it is using random.random and random.random method. So these two will get a random values. And we again have a predict function, same. Okay, so hungry and this. And now we have a learn function also, because now the weights are to be learned. Understand? Okay. Earlier, we had this only, and we were saying, okay, what happens when the weight are this, what happens when the weight says this, and so on. Okay. So now we have a learn function. Now just try and see what is happening. So you have hungry, food available, and label also. So it will learn through labels, right? It will check where are the errors. Why errors are coming? Because what is the reason of error in this case? Because the weights that were chosen initially are not correct. Had these weights been correct during the initial phase, then there is nothing to learn, right? So what happens during learning? Again, I am coming to the same statement. It is the identification of most appropriate weights that is happening in the learning process. So this example should actually give you a very clear understanding of what is happening in learning. So def learn. Now what we are getting is error. Okay. So self dot predict. So this predict function is called hungry food available. So it may so happen that it will give me some answer minus eat, right? So this is giving me the answer as 1 or 0, and I will get some error. So if it is 1, 1, then it will be, if both are 1, error will be 0. That means if both the answers are same, that is the label eat and the answer predicted by the predict function. If both are same, then error will be 0. But if both are different, there will be some error. So learn is being called again and again. Now let's see what is happening. So we are changing the weight. So if error is there, then obviously error is coming because of both W1 and W2, right? So what we will do is we will reduce the weight. We will do weight 1 equals to weight 1 minus error into hungry by 100. Now divide by 100 is actually the rate we are trying to fix over there. We want the weights, the initially assigned weights, to change very, very slowly. Gradually they should change. If we are going to change it very fast, we might miss the optimal weights. Okay, so you compute the error, and depending upon the error values, you make the changes in the weights. So this is actually the learn process. Okay, so we do not want to change the weights too much at a time, and we wish to take very, very small step towards the solution. Okay, so we divide the error by 100 and updated the weights accordingly. Now let's see. So we have a class available. So this is the complete class which is available, and that is what is the neuron over here. Now what we are trying to do is we are trying to use this neuron to predict. So neuron has been there. Now we are doing the learning process. Now we are doing the training process. There is a learn function available. We are doing the training part. Okay, so test part and train part. You test and you train. You test and you train. So this test and train function is written outside the model. This is my model. Neuron is my model. Okay, this model is capable of learning because it has a learn function available that has been written. Now, if neuron.predict equals to 1, and so what we are taking the whole of the data. Okay, so on testing, if we find all the answers are correct, we will break this. Otherwise, this loop will continue. This is while true. So we'll keep on doing the learning process unless this testing gives me the correct answer for all the data. So while true, if neuron.predict equals to 1, so we call this neuron and we use this neuron and we use this neuron to test the data. If all the answers are correct, fine, that the neuron has learned perfectly. But if some of them is wrong, then train. Neuron.learn for this, for this, for this, and for all 4 of them. Okay, so what will happen when we give this input 1, 1, 1? The learn function will be called. This is the learn function. It will first find out the error. 1, 1, 1, what is the error? If there is no error, then obviously there will be no change in the weight. Then it will take the next input 1, 0, 0. It will again figure out the error and so on. Is it clear? So this training will continue while it is true. It will train. Some weights will be adjusted during the training phase, and then for those weights, the testing will happen. If all the 4 answers are correct, the test will break. Otherwise, it will go on learning. Again, weights are adjusted slowly, and then again testing, and so on. This loop will continue, and at some point of time, it will be able to find out the optimal weight. And remember, we find out that 0.6 and 0.8 are optimal weight, but it is not at all necessary that this learning process will generate that 0.6 and 0.8. It may generate 0.62 and 0.89 or 0.72. It may so happen. Okay, so it is very much okay. And then we are once the model has been trained, once this neuron is trained during this process, we are using this neuron to predict our answers. Is this process clear to all? Anyone having any doubt exactly what is happening? So when we are creating a class, we are creating a model. Over here, we are training the model and testing the model. Continuously, we are training and testing, training and testing. This goes multiple number of times, and the correct weight, optimal weights are created. So the model has learned, and now when we are using our model, this is the trained model. Anyone having any doubt in this thing that I have explained over here? Shall we proceed? Are we on the same page? Are you still there? I hope nobody has gone for sleep.
Yes, ma'am.
No, ma'am.
Okay. So this is quite clear. In case you have doubt, please do let me know. Now we are writing a complete program. Why should I call this in this way? Okay, I should do the complete program for training and testing, and my data is also there. So again, I have import render class neuron, the same class that we used, and now we have the data. Instead of manually putting this data, we have created an array of our data, and now we are defining the run training. So training will run testing will run. So instead of making this testing and training written inside a loop, we have created 2 different methods, run training and run testing, and the learning process is going on over here, and that's it. So now what is happening? What is this run training doing? It is taking the neuron, and it is for row, these are the rows. It is picking up the data. So it is passing learn. Remember, during the training, it will learn, and during testing, it will predict. So your neuron, if you remembered, your neuron has 2 functions. One is predict, another thing is learn. So your model is capable of doing it. So during training of neuron, you are using the learn method. During the testing of neuron, you are using the predict method. Okay, so you have created a neuron, and while true, okay, it will continue to go like this. So output equals to run testing, print output. If output equals to this, break. So if on testing all the outputs are correct, then fine. Otherwise, run training, keep on training. Okay, if on testing the output is correct, and so on. Is it clear? So we initially created a predict function, then we created a neuron which has a predict and learn method, and later on we wrote some code where we are testing and learning, we are training and testing, and then we actually we created 2 different methods for training and testing, and this training and testing will continue until for this given data, the output is correct for all the input datas. So every time you will run this code, the number of steps required, that means number of times this while loop will work will differ, because initially the random values that you are picking up for assigning the values to weight are different, and therefore number of times this code will run to achieve to the optimal weights will vary, right? Now, instead of picking some random value initially, if you have some intuitive feeling, if you have some idea about the weight, you may initialize the weights instead of randomly. You may initialize the weights with those values. What will this will help you in reaching the this will help you in reaching the optimal weights quite fast. Yeah. Okay, so now anyone having any doubt in whatever has been explained? Yes. Now it may so happen that now this neuron has been trained on the given data. Now if we change the data like this, in this case we have changed 101, we have changed the data. Now it may so happen that it may take more step to reach the solution. And in some case, it might never reach to the solution, like in this case. If this is the input data and your model has been trained, the neuron has been trained on, neuron is being trained for this particular data, probably it will never reach the solution. The loop will go infinite, right? Because of this last one. Okay. So 001, you will never get it, right? You can try this code on your own if you feel like. Okay. So now we understand. So now why we continue to loop in this case? Because the threshold we are putting is 1. Okay. Instead of 1, if we put it -1, probably things will solve. That is, if this value is greater than -1, then it is okay. Okay. So you will be able to resolve all the issues. So this threshold, can you see this? Initially, what is this threshold we are taking up? This is, we are taking it as 1. Okay. And because of that, in some cases, it is giving the right answer. Like if you change the data, it is not giving the right answer. So why to take threshold as 1? You can take threshold as random value also. Okay. So in this code, you are taking class neuron. This T, which is the threshold, that means that the sum should be greater than something or less than something. So instead of taking it as 1, we are taking it as threshold. Okay. So all these things, initial weights, threshold values, all these things are parameters. Okay. So I hope this thing is making sense to you now. This is the learn method. I hope this is quite clear to all. Okay. Now some of the ML terms. Bias. What is a bias? The threshold T that we have taken initially, that is what is bias. Okay. Parameters W1, W2, T are called parameters. Variables, these parameters are the variables that we are trying to learn. Okay. The act of selecting the parameters is called parameterization. Model, over here the model is the neuron. After training, we will have good values of W1, W2 and T, which is weights and bias, and these weights and bias will produce correct outputs, and this set of value parameter is called, so when we train a model, actually we are getting good values of the weight. So what happens in the learning process? During the learning process, it is the weights that are assigned, optimal weights are assigned to the parameters. Is it clear? The set of values of the parameter is called the value. So after the model has been trained, what you will get? You will get the set of values, right? Learning rate, another important factor. So when you adjust the parameters, if you get some error in to what speed, at what rate you want to adjust the parameters. You want to adjust it slowly, so you are dividing it by 100. If you want to adjust it very fast, so your learning rate is 0.01. If you put it 10, your learning rate will fast. But what may happen is you may jump the optimal answer. Okay. Learning rate is denoted by, generally it is denoted by alpha. So it is one of the hyperparameter. Now somebody was asking me, how do I know what are the reasons my model is not working correctly? Okay. Now there can be various reasons, but first thing is you see that whether you have the optimal data available to you, or there is a large amount of data available to you or not. Second is these hyperparameters, whether you are using the learning rate, whether you are not using very high learning rate. Your learning rate should be slow. Slow learning should be there. Okay. So learning rate is very important. Again, this learning rate is not a hyperparameter. It is not, learning rate is not learned during the process, but it is the rate which user or coder is assigning, the programmer is assigning. Okay. Then there is something called gradient descent, the algorithm that we have learned for learning the function to adjust the parameters. That algorithm is called the gradient descent. Okay. This learning rate, this approach, weight minus this is gradient descent approach that we are using. This whole iterative process for predicting, calculating error, then adjusting the parameter, this whole process is regression. Okay. We are training this neuron to do linear regression. So this complete process that we have done is linear regression, and the number of loops that are happening for training and testing purpose is known as epochs. So are the terms clear? Parameters, threshold, epochs, learning rate, gradient descent. कुछ समझ में आया? I hope something is clear in this case. Yes.
Ma'am. Yes.
Ma'am,
Even if
I
Yes,
have
ma'am.
one question.
okay.
Ma'am, when we are taking the threshold parameter T as to be randomly chosen, so that will depend on the problem which we are solving, because in our hungry and eat problem, it should
Yes,
always be 0, 0, 1.
yes.
Okay, that means it will choose the threshold according to the problem.
We are not choosing the threshold. Let the threshold be decided. Let the threshold be used as a hyperparameter. Okay, if you are going to put it something, then somewhere it will work, somewhere it will not work, because you are looking at a very limited data, right? Threshold or bias should always be chosen randomly.
Can you give a real life example, like the one which you had given, that eat food available and hungry? Can you give an example where we can leave the threshold to be randomly chosen?
In this example only, you should choose randomly. In fact, on all the examples, you should choose. That is highly advised. Initially, to explain it to you, we chose bias or threshold as one, right?
Okay.
And then there were, I showed it with various datas, like somewhere it will work and somewhere it might not work, right? Because you have chosen why it is not working. For some of the data it is working, and for some of the data it is not able to find anything, right? Like if your
Yes.
data is like this, okay, wo to, see, this hungry, food available, eat, have some meaning associated with we humans. But when it comes to machine, it is 101, 011, and so on. But if for these two input, these are my labels, then probably my machine will never get trained. Because if we have started with 1 as the threshold, then definitely all of them will be incorrect. Is it clear?
Okay, ma'am.
Okay, for this
So
case,
to
like for this case, sorry, for this case. Okay, for this case, whatever you give, it will be incorrect. And similarly for this one also. So you should allow the thresholds to be chosen randomly, number one. Number two, the threshold or the bias should also be learnt along with weights. So generally, it is for two parameters. If your problem has two parameters, there are three parameters to be learned. If your problem has three parameters, it is four parameters to be learned. Right? You got it?
yes.
Okay. Anyone having any other doubt in this concept that has been explained? Have you understood the meaning of bias, parameters, model, learning rate, epoch?
Am I audible now?
Sorry.
Ma'am, am I audible now?
Yes, slightly you are audible, though voice is cracking, but you can speak.
Okay, ma'am. Ma'am, actually, I want to know how can we which model is best fit for
Jagat, your voice is cracking in between, and it is very difficult to make out what you are speaking.
okay,
If somebody else may understand what Jagat is asking, I will be better placed to answer this question.
please ensure anyone is willing to be actually higher network issue in my area. I want to know which model is best fit.
Jagat, you can you type your question in question and answer?
I classes also. I want to type question and answer chat.
Jagat, I'm sorry, but I have failed to understand what you are asking. Is there anyone who has understood? Can put this question before me? Is there anyone else?
No, actually, his voice is not. No, ma'am. His voice is not
Actually,
really understood.
that is the problem. Yes.
Yes.
Anyone else is having any other
Jagat, you
query?
could write.
Okay, shall we proceed now?
Ma'am,
Yes.
ma'am, what are the hyperparameters, ma'am? Then now whatever we have seen, threshold, bias, and all these are parameters. Then
These are
what will
called as these are the see hyperparameters are these only.
Okay, both are same.
Yes, that is the term which see generally now what is it like? Like if I ask you, suppose there is a plain wall, okay, and
Okay.
a wall is two-dimensional, and if I ask you to divide that wall, there are certain triangles and there are certain squares drawn on that wall, and if I ask you to separate those triangles and squares, what you will do? You can use a single line to actually separate those triangles and rectangles, right? Single line
Yes.
will be good enough, right? So
Yes.
for two-dimensional data space, a line will be good enough. Now, if you have a room
Yeah.
which has hydrogen and oxygen and you want to separate them, can a line will be good enough to separate the space in a room?
No, ma'am.
No, you will require a plane, right?
Yeah. Yes.
For 2D, you require one. For two dimensional, you require one. For 3D, you require two. For four dimensional, you require three, and so on, right? And all
Okay.
these parameters are actually hyperparameters only.
Okay, ma'am.
Even learning rate is a part of hyperparameter.
Okay. Okay. Thank you.
Anyone having any doubts?
Hello, ma'am.
Yes.
Can you please explain the concept of bias? And what if we not initialize initially the bias in the while making the model, ma'am?
Please come again.
Okay. What is the role of bias in the process, ma'am? Can you please explain that? And what if we don't initialize the bias in the model?
See, what is bias doing? Bias is actually, see, this complete machine learning is a linear model, and you bring non-linearity by using some function. See, complete process mein what is happening? You have some input, you are multiplying that input with some weight, and for all the inputs, you are doing the summation of inputs multiplied by those weights, right? So it is like if your parameters are x, y, z, okay, you are multiplying it by a, b, c, so ax plus by plus cz. This is a linear model, right? And
Yes, ma'am.
then
Yes.
you are uh, 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 giving it non-linearity by using some ReLU function, sigmoid kind of things. Okay, we are not going to get into it right now. Now, this value that you are getting after using parameters and weights, okay, now with what value you have to compare? Because see, you are creating a classifier, or you want to predict some value. Okay, in order to do that, you need to have some threshold that above this value answer will be yes, and below this value answer will be no. Okay, so that threshold is what we call as bias. Okay, now because data is very large and you do not know beyond what value above this answer will be true and below this answer will be false. So the value of threshold actually depends upon what is the data that has been shown in the example also. If we choose, if I say, if the answer is positive, then it is a monkey. If answer is negative, it is not a monkey. How I am saying that 1 and minus 1 according to my intuition or my wish, that is incorrect way, right? Okay, so
Yes.
that threshold, what is the threshold? If my model gives me x value, whether I consider that x value as yes or no, if it is a classification, whether I should take that value yes or no, will be determined by what? That is the threshold, or that is the bias. Okay. In fact, this is a single neuron. How many layers you should put, that is also a hyperparameter, right?
Yes, ma'am.
Ma'am, am I audible?
Yes.
What the question
I
was
am trying
like
from mobile
hello,
now.
ma'am. Hello, ma'am.
Yes.
The thing was like in the hidden layer there is biases we are using, and the output layer there is that is one another thing, and there is also a threshold. And
There will be, see, there will be a
isn't
threshold, there will be bias in every layer you will introduce. You may introduce that. Because what is happening at every layer? Okay. If we talk of, because you see, you will be attending this FDP and there will be many speakers speaking on it, but just my aim over here is just to give you an understanding what is happening, right? So if we have just single layer, and I want the answer yes or no, how it is going to work? For multiple layers, obviously there will be many things which will come into play, but there will be bias introduced in the initial phase, because you are not going to get an answer at that point. Okay.
okay, ma'am.
Ma'am, am I audible, ma'am, now?
Yes, Jagat, you are audible now.
Ma'am, I am connecting my mobile device now. So
Okay.
I wanted to know how to choose, how to decide which model is best fit to test and train a particular purpose. Like suppose I want to identify whether it is a cat or a dog, then on what criteria I have to choose the best model for testing and training, ma'am?
See, first of all, depending upon the data, you will choose a model. Okay. What kind of
Yeah.
data you are working with? If you're working with images and it is just a binary classification, then probably SVM seems to be quite a good model, but provided the size of images is small. Okay.
Yeah.
But as the size of images become large, okay, the SVM model becomes less fit because of the number of points it will have to handle, and it becomes very, very slow as the image size increases. Okay, so if you have to work on images which are of larger sizes, okay,
Yes,
then
ma'am.
probably you will go to neural networks. Okay, but if you have numeric data which is continuous, and you have to do some prediction, then I think linear regression is the best choice, right?
Okay, ma'am.
Linear regression with multiple variables is actually a very good choice. But if let's say you want to predict some, for a question you want to generate some answer, then probably both of them might not work. You might have to go to RNN, okay, or you have to use LSTM models. Clear? So
Okay, ma'am.
it totally depends upon your data, uh, 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 what model to choose. Number one, it may so happen that you choose one model, but you are not getting good answer with that. So you might have to choose another model which is capable of working on the type of data that you are using, right?
Ma'am, what are the interfaces I have to choose? Like weight, height, then sizes, then colors.
For which one? For images?
Yes, ma'am. Yeah, images.
See,
Suppose dogs
see,
and cats are there.
yes. You are, when you are using neural networks, the beauty of neural network is you do not have to identify any of the feature. You just have to give images as pixel values. That's it.
Okay.
Okay, that way
Yeah.
the things becomes quite. In fact, you can use CNN model kind of thing, and things become very easy. You do not have to think of features if you're using images,
Okay,
right?
ma'am.
Features are automatically detected.
Okay, ma'am. Ma'am, how the system automatically detects, ma'am?
How the features see? You have the pixel values available. That is something related
Okay.
to explainable AI. Okay.
Okay. Okay.
So the pixel values are going as an input, and
Yes.
which pixel values has higher importance depending upon the data. Therefore, large number of data is extremely important. Large amount of data is extremely important. Okay.
Mm. Yes, ma'am. Yes, ma'am. Thank you, ma'am.
Okay. Anyone having
Thank
any
you.
queries, or shall we proceed further with the other slides now?
And
Ma'am,
ma'am, one
one
more
question
thing,
I
ma'am, the slides will be shared now, ma'am, please.
Yes. Uh,
Previous
Gulami
slides
Banerjee.
and this session's slides.
yes, ma'am.
Jagat, they will be shared. Huh.
Thank you, ma'am. Thank you.
Yes, ma'am, one question actually I missed out from previous one question I have. Ma'am, what exactly happens in the generative case?
Generative AI, see, artificial intelligence, this machine learning thing is used in two ways. One is either you want to do some prediction or classification. Okay. So prediction is actually generating some answer, right?
Yes,
Predicting the
yes,
price, predicting the weather, whether it will rain or not. Again, some yes or no or some specific value. Or classification, like whether the image has cat or dog. Okay. So that is the common traditional problems related to machine learning. Now, if I want to find out what route a packet should take for going from source to destination. Okay, so the machine model should generate some route, right? What is the best answer for a given question? So it will generate the answers for me, right? So this is this type of artificial intelligence where some answers are getting generated, contents are getting generated, routes are getting generated, right? All these problems fall in the category of generative AIs, and there are specific techniques for it. Okay, is it clear?
Yes, ma'am. And when we use the RNN and LSTM,
Yes, these are used for text-based things. If you want to write answers to small question, you will use LSTM. Okay.
okay,
From the context, from the given text, you want to generate questions, you will use LSTM.
Okay, ma'am.
Okay. Any other query?
I've got a small query.
Yes,
Ma'am, will it be possible for you to share a kind of a chart which indicates when to use which algorithm? Is that possible? Because it'll help us to.
Anubhav, actually, there is no such chart.
Okay.
I can only share, okay, if you have this type of data, probably these type of techniques will work. If you have this type of data, if you have textual data, probably RNN and LSTM will work. If you have images type of data, probably CNN will work or neural network will work. If you or SVM will work. If you have purely numeric data, which is structured, probably regression will work.
Regression, yeah.
Okay. Yeah. Or random forest, if you have data which is continuous values and some are category wise data, some are ordinal data, then probably random forest may work. Okay.
I see.
So it depends upon the type of data that you have. Okay. Now,
all right, ma'am. All right.
Suppose if you have type of data, if you have images, and there are 2-3 methods, okay, for handling the images, for doing the classification using those images. Now, amongst those 2-3 methods, which one is the best? That is something you will have to apply. Okay. Any other query?
All right, so ma'am, in this case, so so we have to apply all algorithms and see the best, output in terms of efficiency and performance.
Yes,
That is
yes. To some extent, you can choose the algorithm looking at your data. But once you have chosen certain set of algorithms, then you have to apply those algorithms to figure out this seems to be the best one.
Okay. Thank you, ma'am. Thank you.
Okay. Any other query? So shall we proceed now? Okay. So let's discuss slightly more on using Python for machine learning. Let me share the presentation once again. So is it visible? Is the screen once again visible to you?
Yes, ma'am.
Okay, we'll quickly go through it because there are many things. We'll just go through the steps. Now, everywhere Python is being used for machine learning. Why? Because what I have understood according to please put your microphone on mute. Please put your microphone on mute.
Please mute yourself.
Please, can you please put your microphones on mute? Okay. Is the screen visible?
Yes, ma'am.
Okay. So why Python is used so often in machine learning? Because of because some of the features in Python are really good. That is one reason. It is providing you function based programming also. It is providing you the capabilities of object oriented programming and structured programming. That is one reason. Other reason is there are lot many packages and libraries available in Python which can be actually used for doing the programming, for training of your models. The neuron code which I showed you is a blank code created from scratch. But if you have other problems, you can easily use various packages and libraries of Python. We'll quickly scroll through it, though I have given some code related to what are the features of functional programming, but I am skipping this part of function programming features of ML. I'm quickly moving towards the features of Python which are used for machine learning. Okay. So
Please make full screen.
sorry, I cannot understand what you are saying.
Full screen, full screen.
Okay, sorry. Is it clear? Okay. So there are a number of libraries in Python which are
Ma'am,
very useful.
no screen is visible.
The screen is not visible.
Yeah.
Okay. Let me share it once again. I think there is some issue with it. Acha, okay, it has lost sharing.
Now it's okay.
Okay. So is the full screen visible now? Is the full screen visible?
Yes, ma'am. Yes.
Sure, ma'am.
Okay. So there are various libraries available in Python which can be used for doing the machine learning. But remember, these libraries are not only used for machine learning, but they can be used for many other purposes. So we'll look at few of the libraries very quickly. So NumPy, I hope most of you have used this NumPy library. This is primarily used for creating multi-dimensional data. If you have lot of data which has lot of dimensions, then NumPy is the solution for you. It is very easy to create array. So over here it has been created, and you can use certain methods which are available, but you will have to actually study NumPy in order to use it. Okay, though some of the things are available, but still you will have to use some common methods. You will have to learn some common method to use NumPy. Then another one is pandas. NumPy is used for arrays. Pandas is used for structured data, tables kind of thing. So pandas is used for data manipulation and analysis, primarily working with tabular data. So you create a data frame. Data frame is like one row of a table. So you have name. It is like data frame can be created like dictionaries in Python. So a label and then the value, label and then the value, and you can describe this data, so it will give you the structure. So you have numpys for arrays and pandas for structured data like tables. Then you have scikit-learn. Okay. This scikit-learn contains the machine learning algorithms for classification, for regression, for clustering. So all the models that you use, we generally use is from scikit-learn. Okay. If you want to use linear regression, Bayesian networks, random forest, all these things are available. So over here, I have given you the example. Okay. So you have to first import whatever model you want to use. Okay. You create a model and then you fit, train and y-train, and then you predict. Okay. This is the simplest thing. Obviously, x-train and y-train have to be there as variables to use. After scikit, if you want to plot your data for visualizing the data, then Seaborn and Matplotlib. Probably Matplotlib you might have used, but Seaborn is something, I don't know how many of you have used it, but it is very simple way for plotting any of the figure. Again, Matplotlib is an extensive library, and you have to actually understand various methods and application of those methods in order to use it. Okay. Again, I'm just telling you what all libraries are available and what is the purpose of those libraries. If you want to use and work with those libraries, you will have to individually take them up, spend a day or two on those libraries, on those packages, so that you become equipped enough, you become skilled enough to use those functions given in those libraries. Okay. Then TensorFlow and Keras. For all the deep neural networks, deep learning, the methods are available in Keras and TensorFlow. So here are some examples. Then PyTorch is another way. Okay. PyTorch is not very commonly used by who by programmers who are very keen on doing regression kind of thing. It is for computational graphs kind of thing. So PyTorch is not that common, but these are the few uh, very important common libraries to be used in machine learning. And let's quickly go through this is the last thing that I'm going to discuss. Quickly go through the steps for building models. So first of all, you have to choose the library. So you have to import the libraries, first part. Second is uh, load and explore the data. If it is images, you have to use functions for IAM-read kind of thing. Okay. If you have textual data, you use pandas. If you do not have anything but you are creating your own data, probably NumPy might be useful for you. So first thing, for pandas, you have to read your data set CVs, CSV. It may be in other formats also. You have to understand what is the format of your data. Is it XML? Is it CSV? Is it something else? So you have to see how to read your data. Okay. This data dot head will print few lines, few rows of the data, so you can see what your data is all about. Then you have to pre-process the data if there are some missing values. Okay. If image is to be rescaled, resized. Okay. Uh, these are the things which need to be done before you send this data to the model. You can use sklearn for pre-processing the data. Then you have to, once the data is ready, you have pre-processed it, there are no missing values. Okay. You have to split the data in the train and test. sklearn is again useful for it. Now over here test size is 0.2, so you have 80% data as test data, train data, and 20% data as test data. Once your data is split, you pick up a model. Okay, decision tree use karo, random forest use karo, linear regression use karo, whatever is available to you, you use that. Okay. Once your model has been trained, you evaluate the model. Okay. You can use various accuracies, precision, either mean squared errors to evaluate the models. Once you evaluate the model, then you optimize the model. You reset the hyperparameters, cross validations kind of thing. And once your model is ready, you deploy the model where you want to use it. Like for monkey problem, for identifying whether monkey is there or not, we have to deploy that model either on Raspberry Pi board or on Jetson Nano, and that board is something which is going to be fitted into the application where it will be used. Okay. Or you deploy this model in a front-end application somewhere, that model has to be deployed. So there is joblib library available for that, and you dump the model. It is the pickle file which gets created. Okay. So these are the steps which are generally followed for doing the for building the machine model. I hope to some extent the overview of these things are clear to all of you. Okay. And I think I should stop over here.
Ma'am, excuse me, ma'am.
Yes.
Ma'am, go to the pre-processing slide, ma'am. That is.
Just a minute. Just a minute. Okay, I'll have to again share it. Hmm. Where is it? Just keep. Okay. Is it visible?
Yes, ma'am. So in that part, splitting the data where we have to give the validation part, ma'am. For test size, 20%.
We are not explicitly giving the validation over here in this case, but you can give that also.
How,
Okay.
ma'am? How, ma'am?
How? Okay, let me show you the code. Just okay. Data set. I used Anaconda. Okay. I'm just sharing the screen. Generally, what we use is this. Let me see the code, whether it is visible to you. Can I put the code on the chat?
Okay, ma'am. No problem.
Let me try it. Put it over here on the slide. I'll create a new one. This should be visible, I think. New slide. Is this visible? Let me increase the size of the text.
Visible, ma'am.
Visible now? So X
Yes,
train, X well, Y train, Y well, train test split, X train, Y train, test size 0.2. Okay. So the complete data is getting split into validation. This X well, Y well is for validation part. Is it clear?
Okay, ma'am.
Okay. I think I can stop sharing now.
Ma'am, one question, ma'am.
Yes.
We are selecting the model by changing the hyperparameters and all. So then
We are, sorry,
like,
come again, we are.
like actually we are by change we are